Friends, in this video we are going to see a problem on convolution sum. The problem is the impulse response of discrete LTI system is given as h of n equals a raised to n into u of n minus u of n minus 5. Determine the output of the system for the input x of n, which is equal to b raised to n u of n, using convolution sum. Let's first draw the given signal to understand our problem. Here h of n is a raised to n into u of n minus u of n minus 5. It means h of n is an exponential signal which starts at 0 and ends at 4. So it's a finite duration exponential signal. Whereas x of n is equals to b raised to n u of n. X of n is an exponential signal which starts at 0 and ends at infinite. So it's an infinite exponential signal. So let's see the solution. Output of the system is given as y of n, which is equals to convolution of x of n and h of n. So we know the equation y of n is equals to summation of x of k into h of n minus k for k minus infinity to infinity. So let's draw x of k and h of n minus k. h of n minus k is shifted and reflected version of h of n, and x of k is same as x of n. As you can see, h of n minus k starts at n and goes back up to n minus 4. Here the start point is considered as n, end point is considered as n minus 4, because the length of the sequence is 4, hence the end point is n minus 4. Since x of k is an infinite signal and h of n minus k is a finite signal, we will have three cases. Case 1, for n less than 0, there is no overlap. As we can see, n less than 0 means n can have any value less than 0. It can be minus 5, minus 4, minus 3, minus 2, any value less than 0. There is no overlap between h of n minus k and x of k. Hence, the output y of n equals to 0 for n less than 0. Case 2 is for n in between 0 and 4. Since the length of the finite sequence is 4, we take the duration between 0 and 4. There is an overlap for any value of n between 0 and 4. There is always a overlap from 0 to n. Hence, the limits in the convolution sum changes as y of n is equals to summation of x of k into h of n minus k, where k is from 0 to n, same as overlap. We substitute x of k as a raised to k and h of n minus k as b raised to n minus k. We get y of n is equals to summation of a raised to k into b raised to n minus k for k 0 to n. Let's solve this summation. First, b raised to n can be taken out of summation as it's a constant. So y of n is equals to b raised to n summation of a raised to k b raised to minus k for k 0 to n, which can be written as b raised to n summation k 0 to n a by b whole raised to k. For this we know a summation formula, summation of a raised to k for k 0 to n as equals to 1 minus a raised to n plus 1 by 1 minus a. Hence we get y of n as equals to b raised to n into, by substituting the formula we get 1 minus a by b whole raised to n plus 1 divided by 1 minus a by b. Further simplifying, that is taking b as LCM, we get y of n is equals to b raised to n plus 1 minus a raised to n plus 1 divided by b minus a. This is for the range of n from 0 to 4. Case 3, for n greater than 4, there is a overlap. For any value of n greater than 4, there is always a overlap for the complete duration of the h of n minus k. Hence, overlap is from n minus 4 to n. The output of the system can be written as y of n is equals to summation of x of k into h of n minus k for k equals to n minus 4 to n. Substituting x of k and h of n minus k, we get y of n equals to summation of a raised to k, b raised to n minus k, same as before, but limits will change from n minus 4 to n. Let's solve this summation here. First we can take b raised to n outside. Hence we get y of n as equals to b raised to n summation k equals to n minus 4 to n a by b whole raised to k. We have to use a different summation formula where the limits are finite. That is, summation of a raised to k for k equals to m to n, which is equals to a raised to m into 1 minus a raised to n minus m plus 1 divided by 1 minus a. So we get y of n as equals to b raised to n into a by b whole raised to n minus 4 lower limit into 1 minus a by b to n minus 4 upper limit minus lower limit plus 1 whole divided by 1 minus a by b. So here we n and n gets cancelled, hence we get y of n is equals to b raised to n into a by b whole raised to n minus 4 into 1 minus a by b raised to 5 whole divided by 1 minus a by b. Further simplifying, we get y of n as equals to a raised to n minus 4 into b raised to 5 minus a raised to 5 divided by b minus a for n greater than 4. Finally, for the given problem h of n, which is equals to a raised to n into u of n minus 5, a finite sequence, and x of n, which is equals to b raised to n into u of n, an infinite sequence, we have a solution as y of n equals to 0 for n less than 0, y of n equals to b raised to n plus 1 minus a raised to n plus 1 whole divided by b minus a for n in between 0 and 4, and y of n is equals to a raised to n minus 4 into b raised to 5 minus a raised to 5 divided by b minus a for n greater than 4.